Hello students, I'm Mr. Ruffler, a high school chemistry teacher, and welcome to the channel. In this series, we're walking through the brand new June 2026 New York State Chemistry Regents exam, cluster by cluster. This is the 11th and final video in the series where we're looking at the indoor air pollution cluster. If you're looking for a different cluster, check out the playlist linked in the description below where you'll find step-by-step walkthroughs of the rest of the exam. Let's get started. This is a beefy cluster, and the first thing we want to do is read the passage for full understanding. So here we go. Many odors in the home are due to volatile organic compounds, also known as VOCs. Volatility is how easily a solid or liquid becomes a gas through sublimation, or evaporation, and increases with increasing temperature. VOCs come from a wide variety of sources in the home. The gases released from the VOCs are inhaled and can be the source of both short-term and long-term health issues. Other indoor pollution comes from odorless gases such as radon-222 and carbon monoxide. Radon-222 is a dense radioactive gas that is able to enter homes through the basement foundation. Alpha particles and a very small amount of energy are released as radon-222 decays. If radon-222 enters the human body by inhalation, it may cause damage to cells and can ultimately cause cancer. Figure 1 shows some sources of indoor air pollution in a house. If we're looking at the figure, we can see that it's trying to show us the source of some pollution. However, I want to take a look at the question and then figure out what I need to interpret from this figure. So let's do that. Question 46 says, which statement identifies a method to reduce the impact of a source of indoor air pollution as indicated in figure 1? The passage states that VOCs are inhaled and can be the source of both short-term and long-term health issues, and then says other indoor pollution comes from odorless gases, yada, yada, yada. Okay, so we know that VOCs are causing indoor pollution. All right, going back to the answer choices, it says that we can store cleaning supplies in well-ventilated areas to reduce a source of indoor air pollution. Let's go ahead and look at the figure. So I look for cleaning supplies, or cleaning fluids, and we notice that they're releasing VOCs. Well, logic would tell you that if we store these in a well-ventilated area, then maybe some of the VOCs will be sucked out of the basement and leave the house. So answer choice 1 is looking pretty appealing, but let's look at the other choices. Question number 2, or choice number 2 says, place carbon monoxide detectors in each room of the house. While this might be an appealing answer choice because carbon monoxide detectors will help you detect carbon monoxide, ultimately it's not going to do anything to reduce the source of indoor air pollution. So we're going to get rid of choice 2. Choice 3 says replace hardwood floors with carpeting. If we look at the passage, carpet is a source of VOCs and formaldehyde. Formaldehyde is also a volatile organic compound. So if we're putting carpeting in, we're actually going to end up producing more volatile organic compounds. That's a bad choice. Choice 4 says raise the temperature in the home. The passage explicitly states that many odors in the home are due to volatile organic compounds, and volatility is how easily a solid or liquid becomes a gas through sublimation or evaporation, and this increases with increasing temperature. If we are increasing the temperature, we're going to cause more volatile organic compounds to exist as a gas, which is exactly what we don't want. So for that, we're going to eliminate choice 4 and select our correct answer, which is choice 1. Question 47 says, write an equation to model the nuclear decay process to illustrate the changes in the composition of a Rn-222 as it decays. I'm going to start by writing the isotopic notation for Rn-222. The 222 is the mass number, which can go on top. We can write the symbol, and then let's go to our reference table to figure out the atomic number for Rn. If we look, Rn is radon, and the atomic number is 86. Right, then we need to figure out what type of nuclear decay radon-222 is undergoing. I do recall it tells us this in the passage, so let's take a look. It says that alpha particles and a very small amount of energy are released as radon-222 decays. So we know that we are undergoing alpha decay. For alpha decay, we can go to our table and we can select the symbol for alpha decay, which I'm going to just use as 4,2 alpha. So I'm going to draw the arrow because we're producing alpha particles. And then we got to figure out what we're left with. Well, we're losing 4 mass, so 222 minus 4 is going to leave us with 218. And then we're losing 2 protons, so that's going to leave us with 84 protons. We then need to figure out what is atomic number 84. So to do that, we go to our table, and atomic number 84 is going to be polonium. So this is our credited answer. While it is worth noting that this is the decay equation, it also says that we release energy. So the Regents did have on the answer key that they would accept that equation. They'd also accept this if you add the energy. All right, moving along. It says figure 2 contains data on physical properties of VOCs. It's giving us common VOCs, their products, their vapor pressure, and their boiling point. So we're probably thinking back to that fast and fragrant lab where we had to do an investigation on vapor pressure and evaporation. Question 48 says, in which list are VOCs placed in order from strongest to weakest electrical forces between particles in the substance? To do this, we need to understand the relationship between electrical forces, or maybe you recognize them as intermolecular forces, vapor pressure, and boiling point. I have 2 hypothetical scenarios here. Scenario 1 is going to have very strong forces, which I'm going to indicate by a thicker line. Scenario number 2 is going to have weaker forces, which I'm going to indicate by less thick lines. In the scenario with weaker forces, that means that more particles are going to be able to escape the solution and become a vapor. Okay, so this is going to mean that we have a higher vapor pressure. In the first scenario, where we have stronger forces, these particles are held in their liquid phase more tightly because they have stronger forces. That means less particles are going to escape, and that means we're going to have a weaker vapor pressure. If we think about boiling point, stronger forces are going to hold particles in the solution better. So that means we're going to need more energy to disrupt those forces. If we need more energy to disrupt a stronger force, that's going to result in a higher boiling point. And if we need less energy, that's going to result in a lower boiling point. So that's a little review of the concepts. So let's take what we've learned here and apply that to the question. All right, so we know that the highest vapor pressure is going to be the weakest electrical attractions. Right, so methanol is going to be very weak. Benzene is going to be very weak. Ooh, formaldehyde, that's a big number. That's going to be the weakest. We'll say toluene will be moderate. And ethylene glycol, because it has a very low vapor pressure, will be the strongest electrical attractions. We want to rank the VOCs from strongest to weakest electrical attractions. So anything that starts with formaldehyde is going to win if it has formaldehyde in it. I'm sorry, we're going from strongest. So the strongest is ethylene glycol. So anything with ethylene glycol listed as the strongest is going to win. Okay, we have ethylene glycol listed as the strongest for choices 1 and 2. If it is excluded in the others, we have to look at the other first one. Like in 3 and 4, we're not including ethylene glycol, but we're starting with the strongest electrical attractions as formaldehyde. But we know that formaldehyde has the weakest electrical attractions. So let's eliminate choices 3 and 4. All right, if we're going to rank electrical attractions by vapor pressure alone, this is going to win. So that's going to be number 1. It's because it's the lowest vapor pressure. The second lowest vapor pressure will be toluene, which is listed in choice 2, but let's continue. The third will be benzene, because that is the third highest number. Then methanol, then formaldehyde. All right, so choice 2 is the most attractive answer. Moving along, question 49 says, what is the mass of formaldehyde? Oh, I'm sorry, I missed the reading. Many common household, building, and medical products are prepared by using an aqueous solution that is 37% formaldehyde by mass. And the question wants to know, what is the mass of formaldehyde needed to prepare 1.5 times 10 to the third grams of formaldehyde solution? Okay, so what we know is we have 37% formaldehyde by mass, and we need 1.5 times 10 to the third grams of formaldehyde solution. What this is ultimately a part over whole question, or a percent by mass question. So what we know is that we want a 37% formaldehyde solution. So I'm going to plug in the percent by mass to be 37%. What we're solving for is the mass of the formaldehyde necessary to produce 1.5 times 10 to the third grams of the formaldehyde solution. So what I'm going to do is put in 1.5 times 10 to the third grams as the whole, because that's the entire solution. The part, which is going to be the mass of the formaldehyde, is what we need to solve for. And then don't forget the times 100%. When I divide both sides of the equation by 100 to get rid of the 100%, this is what I'm left with. I can then cross multiply, and I will get that x is going to be equal to So let's look at our trend for electronegativity. We know that the trend is electronegativity increases from bottom left to top right, with fluorine being the most electronegative. We need to evaluate the electronegativity between the two atoms in the bond. So starting with hydrogen and carbon is right here and hydrogen is over here. Carbon is obviously going to be more electronegative because it's farther to the right. Using this idea, if this is the most electronegative and this is the least electronegative, we know that the hydrogen is going to be partially positive, right? The carbon is going to draw the electrons in closer. If we're evaluating carbon and oxygen, we go back to the table. Here's carbon, here's oxygen. Oxygen is farther right, so oxygen will be the most electronegative. That means oxygen is going to be partially negative. Between oxygen and hydrogen, we go back and look. Here's oxygen, here's hydrogen. This is the most electronegative, which means it's going to be partially negative. So we will assign a partial negative on the oxygen, and we'll assign a partial positive on the hydrogen. So that's it for this cluster and this series for the June 2026 Chemistry Regents walkthrough. I appreciate you watching. If this video helped, please like the video and subscribe for more walkthroughs. If you're looking for a different cluster, I'll link the playlist in the description below. Happy studying.